Alrighty then, hi everyone, and welcome to the first SQL office hours of 2024. It's great to be back. I hope you all had a good holiday festive season. I certainly had a very good time relaxing with the family, so that was all good fun. I say doing a little bit different today. I've got some special guests to help talk about XML. We've got Chin Yu, who's a software development director of Oracle Database Development Organization, and her team is responsible for developing the functionalities and relating to managing semi-structured data such as XML, JSON, and large objects in the Oracle database. So I'm really pleased to have her. We've got one of the experts here talking about XML and how it's working. And alongside her, we've got Alonso, who's senior software developer working on XML. So he knows all the ins and outs of how it actually works in the database. So they know way, way more about XML than I think I've ever known, right? So with that, I think I'll hand over to you, Chin, to get started and talk about what's here and what's coming. So take it away, Chin.
Yeah. Hi, everybody. So I'm very happy today I can give a technical overview regarding Oracle XML DB in Oracle Database 19C and 23C releases. So first, I will give a brief introduction of XML database. So as most of you know, Oracle database is a converged database, so which provides a single platform to store, manage, and process all of your data of any data type. XML is one of them. So we provide XML data model for OLTP processing within Oracle database. We have a native XML type within the database, so it allows the use of XML type to define the column. So the XML documents can be stored, updated, and accessed in the database. We also provide XML data model for analytics. We support operations to query, search, analyze, and integrate your data to allow high efficient processing of XML content in the database. In addition, we also support this multi-model interoperability. We support multi-model transformation via SQL. We also support bidirectional transformation between XML data and the relational data. So basically, you can leverage the power of the relational model when working with XML content. And you can also leverage the flexibility of XML when working with the relational content. So let's first talk about XML type. And this is the sample XML data will be used for this presentation and the demo. So in this sample XML data, you will see a purchase order XML document. In this purchase order, you will see elements like reference, user, shipping instructions, and there is a special line items element in this document because it contains a list of line item elements. In this example, you will see 3 different line item elements. So line item 1, 2, 3, and each of them has the description and the part element. So XML type is a native SQL data type. We introduced XML type based on SQL XML standard. So it makes database XML aware. Because of it's a native SQL data type, you can use it to define the type for column, variable, argument, or return value of a PL/SQL function. It is optimized for streaming, indexing, and fragment extraction. So in this example, when you see create table purchase order, you will find that there's a column called PO_detail. Its data type is defined as XML type. We also provide the PL/SQL and the Java constructors for creating an XML instance from other data types, such as varchar2, club, blob, and the B file. You can load the data into the table using regular SQL or other APIs, such as JDBC, OCI, or PL/SQL. You can also use SQL Loader utility. Now, what is the difference between 19C and the 23C? So in this example, you will see in 19C, we have create table purchase order with PO detail specified as XML type. But you can also specify XML type storage clause. So XML type column PO detail store as binary XML. In 19C, XML type column is stored as binary XML. It's stored as non-self-contained binary representation of XML on disk in the database. Non-self-contained means there is encoding information used to encode the XML data, such as some token information. They are stored in a separate centralized token table. If you omit this XML type store as clause, the default storage will be binary XML if your database compatible parameter is specified less than 23. In 23C release, we introduced this transportable binary XML. So in this example, you will see the XML type storage clause is specified as XML type column PO detail store as transportable binary XML. Transportable binary XML is self-contained binary representation of XML. It provides better scalability and performance. It is the default storage for 23C database if a compatible parameter is set to be greater or equal to 23. And transportable binary XML is the recommended future storage model. Now, how to migrate a binary XML column to a transportable binary XML column from like 19C to 23C? You can use online read definition. So this is a feature provided by Oracle database. You can also use the create table as select. So you can create a new table with XML type stored as transportable binary XML, and then select the data from your original table that has XML type stored as a binary XML. We also introduced this new option for this transform parameter in data pump utility. So when you specify data pump import command, you can specify this transform option with this new parameter value, XML type underscore storage underscore clause, and the value you can specify as transportable binary XML. So when data pump import the data on the target database, you will create a table with XML type column, having this XML type column stored as transportable binary XML. Then you will insert loading the data from your source database. So this is another option to use to migrate from 19C to 23C. SQL XML. You often hear the terminologies of SQL XML, XPath, and XQuery when you work with XML documents. SQL XML is defined by ANSI SQL standard as a general interface between the SQL and XQuery languages. XQuery is the W3C language for querying and updating XML data. So in addition to XQuery specification, it also includes XQuery update and XQuery full text recommendations. XPath is a W3C recommendation for navigating XML documents. So it's a subset of the XQuery language. And XPath expression is actually also an XQuery expression. XPath models an XML document as a tree of nodes. So it provides a lot of operations for navigating this tree. Common constructs a slash, which denotes the root of the tree of this document. It can also be used as a path separator to identify the child element of a given element node. // is used to identify all descendants of the current node. Star is used as a wildcard to match any child node. Bracket is used to denote the predicate expression, or sometimes used as a position or index to navigate a list of elements. XPath and XQuery also support a set of built-in functions, such as substring, round, or not. You can find a lot of other functions in W3C specification. So Oracle provides a lot of SQL XML functions based on SQL XML standards. So we have functions for XQuery. Functions like XML exists is used for filtering. XML query is used for fragment extraction. XML cast to convert the fragment extraction, which happens to be a scalar value, to a SQL data type. XML table can be used for projection. We also have a lot of other functions, such as XML serialize. XML serialize is used to serialize XML data into a string or log. XML pass, which pass XML data into XML type instance. We also have functions like XML transform. This provides XSL-based transformation, and XML namespaces for namespace management. In this presentation, we will focus on XQuery-related functions. So XML exists. XML exists is mainly used in SQL where clause to filter rows based on an XQuery expression. It evaluates whether or not a given document contains a node that matches an XPath expression. In this example, we try to look at purchase order table we created. So for this purchase order table, we have a PO detail column that stores all XML documents. XML exists in the where clause, trying to find a reference element under this purchase order element and check whether this reference element has a particular value. If the value of a reference element equals to this value, XML exists will be evaluated as true, so we can return the document. And you can also see the PO detail, which is the XML element column. And this is passed as a PO context item used to evaluate this XPath expression. XML query fragment access. XML query functions used to query XML data. So it's basically to extract the fragment from each document. So in this XML query example, you will see in addition to XPath expression passing clause, there is also a returning content. Returning content keywords indicate the result from the XQuery evaluation is either an XML document or a document fragment. The return type here is XML type. And the bind variables are supplied through this passing clause. So the XML column is passed as a PO, which is the context item for evaluating this XPath expression. You can also bind other value, such as this particular SBEL value for reference. You can pass it as a bind variable and then used in the XPath expression. So when you see this XML exists statement here, you will see this SBEL value, this particular value is passed as a ref bind variable and is used in the predicate expression in the XPath expression here. So if there is a reference element with this particular value for this document, then this document will be evaluated for XML query and its shipping instruction is extracted and returned here. So this is the example for XML query. Now, if you have a scalar value that's extracted from the XPath expression, you can cast this result as a SQL data type. So in this XML cast over XML query example, we try to extract a reference element from this purchase order. Then we cast this reference value as a varchar2. So the return type here is a regular SQL data type of varchar2 here. And you can see the XML exists expression, XML exists operator has a slightly different XPath expression here. The example indicates how to use a bracket 1 to navigate line item elements, try to locate the first line item element, and then to find its part element with the value ID equal to this particular value here. So this is how to use bracket 1 in XPath expression. So in addition to those navigation XPath expression, XML query also has it can also take the XQuery update statement. XQuery update is a standard compliant update of XML content. It's defined by W3C recommendations. So if you want to update XML content, in particularly like a particular one XML column, you can combine XML query operator containing an XQuery update expression with SQL update statement. So you update a table to set this XML column equal to a new value. On the right-hand side, you will use XML query operator. Within this XML query operator, it's actually an XQuery update expression. So if you look in this statement in details, you will see the original value, the XML column, is passed in to this XQuery update expression. It's assigned to a new binary variable, new XML. Then we try to find the target element under this document. Then replace the original target element value with new XML content. Once this new content is generated, it's used by this update SQL statement to update the original XML column. So that's how XML query works with XQuery update support. XML table is also a very useful operator. It maps the result of an XQuery evaluation into relational rows and columns of a virtual table. So it's most used in the front clause of a SQL query in the same way as you would use a relational table. The columns clause extends XML table, allowing projection out of a set of columns. So to form these relational rows and columns of this virtual table. It is powerful because it enables SQL operations on XML contents. It allows applications and tools that operate on the relational model to work with XML. For example, you can have analytical application, report building, or other applications that usually work on relational model. They are not XML-aware tools or applications, but right now you can directly apply them over XML data through XML table operation. And also we have, in case you need to navigate a collection of elements, we can use this chained XML table. We have example we can show in details later. So XML table is used to generate relational views of XML. So you can have a relational representation of the data over XML format. So XML table, let's see how XML table is used along with column clause. So XML table is used to map nodes in the XML document to rows and columns in the result. So for the first example, in XML table clause, you don't see this columns keyword. So in this case, if this column clause is omitted, that XML table just returns a row with a single XML type pseudo column. It is an XML type. The pseudo column name is called column value. So it will return the reference element out as the value for this column value column here. So it does not have this columns clause. So it will just project out a single XML type pseudo column. Versus in the second example, you will see there's an XML table with columns clause here. So for this purchase order, we actually project out 4 different columns: reference, user ID, ship to name, ship to address. All of them have varchar2 data type, and each of them is indicated by different path expression, XPath expression, to extract the corresponding element out. So the final result is like you have a relational view. And for this relational view, for each purchase order, you will see 4 different columns, and each of them has different values. So in this case, it kind of maps this one-to-one relationship between the documents in the original table with XML type column and the rows in this XML table result. So what if you have a one-to-many relationship between the documents in the table and the final result of this XML table result? So here you will see 2 different XML table clauses. The first one goes through this purchase order element, then trying to project out reference element out as varchar2 column. You will notice this second line item column here. So basically, each purchase order element contains a line items element, but this line items element contains 1 or more line item elements. So those line item elements are mapped to this XML type column, and then it passed to the second XML table clause here. So you can see the first XML table projects out reference and line item. Line item column is XML type. It passed into the second level XML table to further iterate over line item elements. And then we project out 3 more columns out: line number, UPC, and the quantity. So the final result is a one-to-many relationship. For each document in the purchase order, you will see 1 or more rows corresponding to line number, UPC, quantity for different line item elements. And the reference value is repeated for all those columns, because reference for purchase order is a one-to-one mapping, but from purchase order to line number, UPC, quantity columns, it's a one-to-many relationship. So that's how you use chained XML table clause to map one-to-many relationship. So we'll see some demo that will print out the result when we run those statements. Now, XML index, you can use functional index to define index using XML cast over XML query, or XML exists. But we also introduced this structured XML index. Structured XML index is used to index fixed structured part of XML content. It requires some knowledge of the XML being indexed and the queries that will be performed. So it is data type aware. Basically, it uses XML table syntax. So it looks very similar to XML table used in the SQL statement. Specific leaf nodes value are projected out into relational index table. So those column leaf nodes values stored as columns. it has very fast extraction, aggregation over leaf nodes, and it is optimized the query with XML table expression. So if you have a SQL query with XML table expression, if you have XML index defined, and those query can be optimized to use those relational index table. So here's an example how we define structured XML index. So we create this index on purchase order table on PO detail column. So within this parameter clause, you will see it is a very similar structure with XML table used in the SQL statements. So in here, we basically try to index part of this structure of this PO detail column in this purchase order table. The first XML table creates this PO underscore P text index table. So it navigates the purchase order element and again projects out a reference column as a varchar2 column. And then it also projects out line item element as XML type. Again, this line item element is actually a list of line item elements under line items element. So this line item column is of type XML type, but it is actually virtual. So which means it does not store any data under this index relational table PO underscore P tab. So it represents a collection and passed to the second level XML table clause. So you can see there's a virtual keyword when we define the line item column in the first XML table. It is passed to the second XML table. So we further navigate this line item element and project out 3 different columns. And then the second index table is specified as li underscore tab in the second XML table clause here. So this is how you define structured XML index, which has a very, very similar syntax as XML table. Now, if you have XML structured XML index defined, and you have a query with XML table clause, but further you can create a view, a relational view on top of this select clause with XML table operators. So basically, as you can see, the definition here for XML table is very similar to the structured XML index definition. If your XPath expression specified within XML table operators, they match the definition in the structured XML index, those queries will be optimized through structured XML index. The final result is just the query will be get rewritten and queried directly from underneath index tables. So you will achieve very similar query performance, just like you query on relational tables. And once you have a relational view defined like this, and then you can issue any query on top of this relational view. You can also do a join, between this relational view and other tables in your database. And your application can work on these relational views directly. So a query like, select query from PO view or join with another table, you can see this is just like you are working on a relational table, right, on relational content. And the application does not really need to know the XML content. So the XML content is really like hidden from the top application. So it's very easy to develop any application from this moment on. And also because you have structured XML index defined, the query can be, optimized for a very, very good performance. So we have kind of seen the direction, right? How we generate a relational representation of the data over XML columns. Now, the question is how we generate XML from relational tables. In the database, we have a lot of relational contents stored in the relational tables. So how we generate XML from those relational tables. SQL XML, again, defines a set of operators that can be used for this purpose. So we have XML element that can generate an element with simple or complex content. We have XML attributes operator, which adds attributes to an element. There's also XML AG operator. It generates an XML fragment. So in most of the time, it's used in a nested subquery for aggregation purpose. There are also a lot of other operators like XML forest, XML concat, XML content, and more. So here is a very direct example here to show how we generate XML from the relational table. In this example, it queries on employee and department relational tables. So we use XML element for element node, XML attribute for attributes node. So you will notice here, within the top level SQL query, there is a nested subquery. It select XML AG on top of this XML element on employees. So basically, it will generate a collection of employee elements under the employees element. So basically, this is how XML AG is used in the subquery to generate a fragment of XML documents. XML schema validation. So in order to validate XML document against an XML schema, we have this DBMS underscore XML schema underscore util package. It's introduced in 19C, and it's available for both on-premise database and in autonomous database. It validates an XML document against XML schema. So there are two APIs defined within this package. There's one procedure called validate. There's also a function called conforming. Both of them take one document, which is XML type, and one XML schema, which is also XML type. The procedure will raise the error if the schema is not valid or the document does not conform to the schema. The function just returns 0 if the schema is valid and the document conforms to the schema. So note there, we used to have this DBMS XML schema package, but this package is not available on Oracle Autonomous Database. So this is an example how you can use this DBMS XML schema util package. You can just call this validate procedure in this PL/SQL logic to validate the XML document against an XML schema. You can also call this conforming function and then assign the return value to a local variable. And then you can check whether this validation is successful, and only you can load the data when the validation is successful. So you can add, different logic in your application to validate the document, before your further, action, such as loading the data into table. So this is just a simple example here. So now I think Alonso will take over. He will run the demo on autonomous database. So you will actually print out the result of those queries I have shown in the presentation.
Right. Okay. Hi, everyone. I'm going to run the demo that she just explained in the presentation, in the slides. So basically what I'm going to do is, guys, I'm going to step by step on the purchase order, the XML document that she used as an example. I'm going to use it as well. and basically do all these XML functions in order for you to see how does it work. So first of all, I'm gonna create the purchase order table. As you may see, here's the XML type column, and it is stored as transportable binary XML, which is a new storage type that Shin explained. So if we run this, yeah, here we go. It is created, and what we actually need to see is the way that it is stored in the database, right? So here is the storage type is transportable binary, which is the new storage type that allows XML to be transported, as its name says. And this is the new way for us to work with XML. There is also the old way, let's say it as that, from 12C to 19C, which is was defaulted, which is not transportable or just binary alone. Oh, sorry, let me just drop it for you to see. And then recreate it, but now it's not transportable. And the difference is that it is only binary. So
just 1 second. Can you raise up the query result thing a little bit, just because it's like drop it.
Oh,
there we go. That's better. Perfect. Thank you.
That's better. Oh yeah. Okay. Yeah. Sorry about that. So yeah. As you may see here, it is now stored as binary XML, which is was the old way for us to store us in the database. And this was based on another internal mechanism, based on a central token table. So let's just keep working with that. Okay, let me just, then let me insert the XML document that Shin showed. So here's the purchase order. Here's the schema. Here are the references and all the items, sorry. And this is just a simple insert. As you may see, we have the ID and the XML document. So I'm just inserting this into my table. So it is now inserted. I hope you can see that it is one row inserted. Does it show actually? Yeah, I think so.
Yeah,
and then
we can say it.
Yeah, and let me commit this. Right. Okay. So this is going to be the document that we are going to work with, as Shin mentioned in her presentation. So the first thing we're going to do is the XML serialize operator. So this XML serialize is going to transform the XML into another storage. Well, not storage. Well, another data type. In this case, I'm going to return a club. And basically, what I'm going to do is also do a predicates, which is using XML exists. So this is going to look into the XML for a purchase order with this reference. And as you may see, we are passing the XML type column, which is PO detail. So what we want to see with this is the XML that complies with this reference, right? So here's the reference. Here we're basically doing the X query in the XML document and getting all the items that have that reference. So this is the first one that is used XML exist in order to filter out our results. The next one is going to be an XML query. So in this XML query, we're going to look into this path, into this XPath, and we're going to return whatever it is there. So in this version of ADB, we do not have the patch to actually get the XML. So that's why I'm adding this get club val. It is already patched, but I don't have that version in this very demo. But just as a workaround, a little workaround here is just the get global. And so after we get this XML query, well, this content of this path, we're gonna again filter out that with the XML exists, again using this reference, and this basically looks as follows. Yep. So as you may see, the output reduced because we're just looking into the shipping instructions. So we are just gonna get the shipping instructions of that item with this reference. So this is all XML, but we are actually using our XML operators to navigate or to go across and search across the document. So the next one, it's gonna be an XML cast. So XML cast, what it does is get the output of certain XML query search and transform it into whatever you want. So in this example, we are looking into this path, the reference, and we're passing the XML type column, and we're gonna return whatever we found there. And so this is the XML query, and then we're gonna cast it as varchar2, and this is gonna be our reference. And again, we're gonna just filter out the output now by looking into the line item, the second line item. And we are also using another property of the XQuery, which is a built-in like a predicate within the XQuery. Because here we're saying that the ID must be a variable, and variable we're gonna say it's this number. As you may see, we're passing the detail as P0 or PO, which is here, and we are passing this ID to the variable called ID, which is this one, right? So basically, this is another way to filter out and to, again, take advantage of the whole support of the XQuery and get the results directly from the XML without needing to transfer everything to another table or whatever. And here it is. I mean, we're trying to get the reference casted as a varchar, and this could be actually an input for another query. So this is already a varchar because of the XML cast. So that's about that. The next one that I'm gonna show, it's again an XML cast of an XML query. It's the same. Basically what I'm doing here is where I think Sheena also mentioned in the last one, I specified the XML document to be the XML type column, which is this PO detail, and here PO. But actually, if you don't use it, as here in this example, we already know that this XML type column is the one that is needed to be looked at in the XML exist or in the path. So if we run this, we're gonna get the same results. So this is just an example that we can omit the XML documents here, and just it is actually I'm gonna know that we need to look into this. Well, this path is for this XML type document. So that's about that. And then let me just get to the next one. The next one is again an XML cast of an XML query, again a reference. But here we are using a predicate varchar2 as well. So we can use XML cast as well in the where clause. Here, what we are filtering out is that in this path of the user, well, we're gonna transform it as a varchar2. And we're gonna try to look for all those strings that start with S and then whatever, right? This is the whatever pattern follows. So here's the results. So this is what we're looking for, because the user starts with S, and then we have, well, we're looking for whatever is there. So it's this is to show that we can filter out also using the XML cast on an XML query and the XML document as well. So the next one, sorry about that. The next one is the XML table. So the XML table can be used as another relational table. We are here first querying from the purchase order, and there we are doing, we are also building over that the XML table. Again, this is the XPath, and it shows that we're gonna use the PO or the P0 and purchase order. This is the path. Here's the XML type column that we're gonna use as the XML document. And here is the interesting part, because we're specifying what columns we want from this document. So basically, we are saying that we want one column named reference of type varchar2, and the path is reference. So this is the parent path, and then the reference child is going to be a column as a show as a varchar2. And we are querying here the reference from that XML table. So we run this. Yeah, basically we have this, we have the ID, and yeah, we are getting the reference out of the XML document with this XML table. Yeah, and this is actually a varchar2 of 30. So the next one, let me just show this. So the next one is gonna get whatever we have from this purchase order reference. So basically, the reference could be another XML type, and we're gonna get whatever we have underneath that path. So as you may see here, yeah, we are getting actually an XML, which is with tags reference. So we can also get out of the XML table an XML type. The last example was to get a varchar2, and in this example, we are getting the actual XML type as well. So we can play around with that, the returning types, in whatever our application needs. So that's about that. And then in this example, I'm also getting the reference, and now I'm getting more columns. As you may see again, here's the path, the parent path that we want to look into. And here are more columns that we want to represent as relational from just only an XML type document. So again, a reference with this path, we can have a user ID of this type with this path. We can have a ship to name with this path, and we can have also a compound path, say a parent and a child within the whole XML document that we're looking into, and also the ship to address. So this is kind of an expansion or to see that we can use for more columns. So here it is. We are getting the user ID from this path, the reference I get from this path, and we can actually get the ship to address, ship to address. Get it done. Yeah. Right. So yeah, we are analyzing or looking into the XML type document with XML table as a relational table. So that's XML table. And now we can actually have joins with XML tables. So this is the relation that Shin explained, one-to-one, one-to-many. We can have that as well with XML table. So in this example, we're again looking into two different paths, as you may see here. We have purchase order and line items. And this could be looked as two different relational tables, as we could have another tables with different DDL. But we only have the XML type documents, which is our PO detail, right? Which is here. So we are again using this PO detail just to feed our XML table. And what we are using is also we are using this line item from the first XML table just to feed the other one. And then we are filtering out with this UPC, right? So this is just to see that we can actually join different XML tables and actually get the result, make all this relational logic, again, using one XML type document. So this fits this second XML table, and we do the one-to-one relation, and then we just filter out the whole result. Okay. So the next one I'm gonna show is another XML cast over an XML query. And again, I'm gonna just filter out by the XML exists. I think it's just a repeated one. I mean, this is just a barcode too. We already see that. And what we wanna do in this example, or what I want you to notice, is that for this path, in this with this reference, we have this name, right? SBL. Because what I'm gonna do next is just an update. Just paste here so we don't lose track. So here we can actually update our XML document by using an XML query. So all this is X query. We're copying the document and we are modifying for every occurrence of this path or whatever user we have. We're gonna replace the value, whatever we have in this user, we're gonna replace it with this variable, P2, and we're gonna return I, in this case is the copy, right? So, and then we specify what we want to, well, our variables basically. So first we have the P1, which is the PO detail, and it's this one. So basically we are analyzing, we are working with our XML type documents. And we are copying into I. And then we're saying that our variable P2 is king. So whatever we find in this path is going to be stored as J. And then we're going to replace J with our variable P2. And P2 is king. So basically, the SBL that we saw in this query is going to be replaced with a sking. Yeah, and this is to filter out, right? Because this is the same filter as we used here. So we're basically, just doing it for just this user, just for you to see how does it look. So we run these updates. We already updated, and if we rerun this query, now we have a sking. So this is a way just to update our XML type, again using the X query, and all the built-in functions and operators that we have there, like modifying and replacing. So yeah, this is just to update. And then I'm gonna go over the index parts. So as she mentioned in her presentation, we can actually enhance the performance, improve it by using indexes. And this is an extractor index. And basically what we are saying here is that we are using the XML table. Again, if you remember, she mentioned that we are using the virtual column, because we're not actually storing anything. We're just using it as to fit the next reference that we want to look into, which is this one, a light tab. And we're gonna get we want to get these columns, right? So this is just to create our index. Let's just go ahead and create it. And what we're gonna see then is just an example with a view. So in this view, we're gonna use the exact same path. So if you remember in the slides, this structure index requires that we know our information. We have, we basically have knowledge of our structures, our paths, our children in the XML documents, just for us to make it faster and the indexes accurate. So in this view, I actually using the same XML table again. And again, I'm using the line item, and this is the very same that we have here, just for us to use the index basically. So let's go ahead and create the view. And what I want you to see now, well, this is just a query of the view, but what we want to actually see is the plan. So let me just bring it up here. Just a second. Here it is. Nope. Here. Okay. It's really small, right? Let me just. Oh, here. Opening a new tab. And where is it? Expand all. Okay. So you can see the plan, right?
We can see a bit of it.
Yeah. Okay, so let me just, okay. Right, so here, what I want you to see is that we're actually accessing the PO tab as a table, as a relational table. And we can actually, equal the performance of the relational table using the XML table. Because we're actually using the same logic and the same mechanism. And here's the index that we just created. So that's basically the functionality that I wanted to show here. Is that we are this POP tab, and let me find the other one. where is it? Yeah, here. li tab, which, as you remember, is the XML table created within the query, is actually treated as a relational table. So these kind of indexes can improve our performance, and it's going to be almost the same as a relational. So the next example is about XML generation functions. We're going to create another table called emp for employees, just here. And we're going to do some inserts. Just a second. I'm going to do these inserts. And let me just commit this. And also we're going to use departments table. And we're going to insert just one row. And again, commits. And so this example is about XML generation functions. So the first one is about XML elements. XML element, what it's gonna do is gonna get the column that you specify, in this case, department number. Well, this is the attribute. This is also generation function. And here's the XML, the column that we're gonna use to create our XML, which is the name, the department name. And the tags that we're gonna use is our name. And we have another also called employees, and we can embed one query within, a subquery within this XML element, which is an XML lag again. The XML lag, what it's going to do is to gather everything together. And we can have another XML element called employee with this attribute. And we have another one actually called XML forest that is going to take the name and the hire date and make all the rows that we have for those columns. We're going to have it in different children for the final result. So let me just print it here. Let me expand this. Oh, it's the second. Where is it? Here? And here it is. So as I mentioned, the department ID is 10, which is the attributes. Here it is. The ID is an attribute, and then we have the names. We have the employee. Well, we are here, and we are doing these employees. And when we get into the employees, which is all these are all these ones, this is the result of the XML forest. So we have all the names and all the hard dates. Here, names and hard dates, which is start dates, as a child, right? Within the employees that we just specified. And yeah, basically, that's the fastest way for us to get to new XML documents. You have the need just to generate by using the XML functions and only relational tables. So the last statement that I'm gonna show is our way to validate our schema. So as Shin mentioned, it is not supported in ADB, the schema validation. The schema as well. So we have this procedure just to do this schema validation, and we support only one schema and only one XML at the time. So it's limited in this version. But yeah, basically what I'm showing here is a schema, which is this one, that we want to validate against, and our XML type, which is this one. So basically what we're gonna say is this XML type, does this XML type comply with this schema? And basically what I'm saying is using this validate procedure. And whatever it returns, which is a conforming function that Shin mentioned, we are using the document and the schema. So this is gonna validate against the schema. And if it is 0, then everything went okay. And if it throws an error or whatever it throws, then we have an error, right? So this is the last. See if it's actually valid. It should be valid. Yes, you may see here schema validation succeeded. So yeah, as Shane mentioned also, we do not have the full support for schema here, but we have these validates just using one schema and one XML document. Actually also does the job. So yeah, that's about it. That's all I have. This all information was also explained deeper into the slides that Shin mentioned. It is the same document. I'm just showing how does it look. Yeah, that's all on my side. Yeah.
Okay, thank you, Alonso.
Yeah.
Okay, so this concludes the demo. So in summary, we provide this unified model for the customers to store, use, and manage both relational data and XML documents in a single converged database. We allow flexible relational XML access of your data, and we leverage all the Oracle database's core enterprise features for availability, security, scalability, and performance. So in general, it simplifies your work and reduce the cost. If you need further information, you can go to our website for white paper, the documentation, and we also have a live lab on our webpage. Okay, so we'll go to Q&A.
Do you want me to read the questions out to you, Chin, or?
Yeah.
Okay, so there's a few questions coming to Q&A, and if anyone's got any more, then please put them in, and we'll go through them. So the first one, I'm not sure I understand the question itself, but it says, does XML 23C storage affect the limit on 23C developer? And then it's got in brackets 12G, which I'm a bit unsure about, but I don't know if that means anything more to you, Chin or Alonso.
Yeah, so I think 23C developer, my understanding that this probably refers to SQL developer. SQL developer 23C is still based on 12G database. I don't know whether my understanding is correct or here. If 23C developer works on 23 backend database, right, all those features should be available because essentially the functionality we provide is on the database side, right? So if your database is 23C, this new transportable binary XML storage model will be available on 23C database, but it requires you to have database compatible parameter to set to be 23 or higher. If you have your database upgraded to 23C, but if your database compatible parameter is not 23C, it's still, like for example, 19, and this feature is not available.
Okay.
So,
Cool.
so what we introduce here is a database feature, not a feature on the SQL developer yet.
Okay, cool. Thank you. All right. So hopefully that answers the question. If not, please give a bit more information. Otherwise, next one, does SQL Developer do this translation from XML to relational table?
So the example we showed do the transformation from XML to relational table is through XML table operator. So XML table operator is a SQL feature. It's just like you issue a SQL query, you use this operator into your SQL query. So there's really no need for SQL developer to do anything extra, right? So long as you come up with this SQL statement and your SQL statement uses XML table operator to try to project XML data out as a relational representation, you run this statement on SQL developer and it will just, show the result.
Cool. Yeah. Okay. So I think that hopefully that answers. There was just a general question about the recording. So the recording will be available later this week sometime, and it'll be on the office hours Aston site. Just go to the videos tab to check that out. So if you want to check the recording. Back on the kind of XML questions, it says in the relational world, we build an ER model during the design stage of application development. What kind of models should we use when XML will be stored in the database to support the application data layer? So it's more about data modeling.
Yeah, so as we have demonstrated here, right? XML, you can just load the whole XML document as it is. You can declare the column just as XML type column. So it is just one column that includes all your documents, right, into this one single column within the table. So overall, if you have an application that needs deal with both relational and XML data, and you need to store XML data as it is in the database, you can just use this model. And since XML type is just one single column, you can continue use ER model, right? The question is whether you need to further project the information out from these XML documents. And for the information you project out from this XML, how you're going to use it. Are you going to join with some other tables, right? And any other tables, right? Are you going to join maybe integrate it with other applications, right? Such as analytical application, right? So you can use XML table as we illustrated in the presentation, right? To project out. But how you're going to project out is you have to consider, right? Basically, the information you project out, how you're going to use it, right? Initial design, you don't really need to consider anything. You can just project it out as it is, just have a create this relational view over this XML table query. And then, so once it's projected out, it's just like a relational table. You can further, have further processing, like do joins or other integration with all other applications. So basically, if you just design the table, you can continue use ER model. And then if you use XML table to project information out as relational representation, you can continue to use the existing modeling mechanisms here.
Okay, cool. Thanks. Oh yeah, and they're saying thanks for clarifying. So that's a good answer. All right then. So I think there's one last question. I think it's probably an interesting one and probably a good one to end on. So what is Oracle's recommendation when to use XML and when to use JSON? Inside Oracle, which type has better performance?
So XML has been around for many releases. JSON is a relatively new feature within the recent releases. So generally speaking, we have very similar functionalities between JSON and XML. XML is more like a document-centric application. In general, we see a lot of applications need to deal with XML documents in the financial world, in the healthcare, because there are business kind of those standard XML schema defined in the financial and in healthcare world. And then the documents for those areas tend to be very large. So in those cases, we do see a lot of usage of XML. In JSON, on the other hand, is very nice to handle relatively small documents. Both of them, we provide a very similar functionality, and both of them we try to optimize. So basically, to achieve a very good query performance. So basically, I would say it really depends on your usage scenario. In the recent release, we see more and more adoptions of JSON documents. It's more or less it's to describe a certain usage scenario, right? Like relatively smaller documents, but really on the XML side is really more or less for a very, very large document. So I would say both of them have very similar functionalities. For JSON development, because it's new and we have more experience, and we can do more optimization to have better performance. It really depends on your application. Yeah.
Okay, that's great. So I think it was one last question come in that I think we'll finish on. So is there an XML data guide like there is a JSON data guide available to kind of explain the structure of XML?
There's no current functionality like JSON data guide in the XML side on the XML side. Usually for XML, the schema is already kind of available. And then a lot of time you need to validate the document against this schema. There's no like a JSON guide functionality that you can derive the schema information from the the document already. Yeah.
Okay, fair enough. Well, they say I think you've given us Chin and Alonso, you've both given us a great detailed overview into XML and Oracle database. I think some good comments about the demo. Any final questions, comments you want to say before we say goodbye?
Yeah. Just feel free to refer to our doc. If you have any other question, we are happy to answer through emails.
Okay, cool. Great. All right then. Well, thank you both for joining us, and thank you all for watching and joining us here, the first office hours or SQL office hours of 2024, I say. Hope you enjoyed this. More importantly, I hope you learned something, and hopefully we'll be back to see you again next month to talk more about SQL and Oracle database. Right. Goodbye, folks.